All right, 1-5 in geometry. Today we start off talking about adjacent angles. That's a funny word, adjacent. Adjacent angles are basically two angles, or it could be more than two angles that touch each other, like they share a side, but they don't overlap. And once we get this written down, I'll show you some visual examples, but it's angles that touch each other. That means they basically share a side, and they don't overlap. So here we have some examples about things that are adjacent. See angle 1 here, I'll highlight him in orange. And then angle 2, I'll highlight him in green. Do you see how they touch each other? They share a side. I totally highlighted a ray, orange and green at the same time. And they don't like overlap. So like if I was to shade this guy in green and I was to shade this guy in orange on the interior, nowhere did orange interior shade overlap green interior shade. And that'll be the same thing here. Here's some angles. There's an orange one, angle 1, and a green one, angle 2. Do you see they share a side? They totally touch each other, right? And if I was to shade in the inside, I never got orange shade over green shade. Those are called adjacent. They touch each other and they don't overlap. Here's some examples of things that are non-adjacent. So angle 3, that would be like this orange angle right here. And angle ABC, check that guy out. Let's use green as bronze steel. Angle ABC, if I was to highlight from A to B to C, it's true that they touch each other, but if I was to shade in this orange guy right here and then shade in the green guy, can you see that the entire orange one is on the interior of the green one? And that's not good, right? That's not adjacent to each other. And then the other example why is if I had this green angle 3 and this orange angle right here, like even though they don't overlap, they never touched each other, right? They're non-adjacent, right? So you can have adjacent and non-adjacent. So let's draw some stuff. Let's use the straight edge of our geometer. We need to draw what they tell us. So acute angle 4, right? So, and obtuse angle 5. So, and they have to be adjacent. So they got to touch and not overlap. So I'm going to switch to my ray maker right here. Use your straight edge. I'll draw acute angle 4 first. So I'll draw a straight edge, and I don't have to measure it with the protractor. We don't need to do that. So angle 4 right here, and then I'm just going to make up some sort of measurement. That to me looks like about 40 degrees, you know, so it's just a rough estimate. It's definitely not like 70 degrees or anything like that, but he's definitely acute. And then I need an obtuse angle 5. Well, since they're supposed to be adjacent, they got to touch each other, right? So I'm going to like basically make them branch off of this guy as the same like ray that they share. So I'll get rid of that, and then I will grab my Raymaker tool again, and I'll just kind of go like this and call that like angle 5. There's plenty of different ways you could have done that, but can you see like from here to here, that's basically like 130 degrees-ish or so, something like that. So doesn't really have to be perfect. Definitely want it to be straight, and we want to like put what they told us to do in there. And then same thing here, draw angle 6 and angle 7 as non-adjacent angles. So it doesn't tell us anything about them being like acute, right, or obtuse or anything like that. So, but the easiest way, in my opinion, to do it is just to make them like not touch each other, right? So I'll draw that angle right there, and then I went the wrong way. So I like to kind of just go this way, and it's like, all right, now I guarantee those two aren't going to ever touch each other. So there's tons of different ways to draw them as non-adjacent angles. You could have drawn one inside the other like we did up here, you know, but it's just, hey, what do we got to do to get the job done? Complementary angles, you probably heard that back in middle school. Complementary angles are two angles, not 3, not 4, not 1, 2 angles exactly that add up to be 90. That's the magic. It's got to be 2 and exactly 2. So draw a pair of adjacent, means they got to touch and not overlap. Complementary means they got to add up to be 90 degrees, angles 1 and 2. Well, I will start with a little cheat code. Since they have to like add up to be 90, I'm going to like make the overall giant picture. It's like, that was a bad deal right there. But I'm going to just make them like be 90 degrees already in that case. Like there's the 90. And then to make them be like 2 different adjacent angles, I'm just going to put like one of these guys in there in that case. So here's angle 1 Here's angle 2, and they add up to be 90 right there, so I'll put the right angle box. If we haven't seen that before, that means that they're 90 degrees, but I think we talked about that last time. And then you could make up some measurements, like this could be 30 degrees and that could be 50 degrees or whatever, right? But the main thing is that they touched each other. They were adjacent. As you can see, here's angle 1 right here in orange, and here's angle 2, right? Didn't switch colors. In green, they touch each other and they don't overlap, right? Those are adjacent angles, and they had to be complementary, so they add up to be 90. Draw a pair of non-adjacent, and that means basically, in our own words, that they're not going to touch each other. They got to add up to be 90, and they got to be called angles 3 and 4. So here we go, right there. I'll do this guy. Let's just say he is 60 degrees right here, and then I got to make my other one. Well, it's like I'm kind of forced to make the other one a certain measure. If this is 60 and they got to add up to be 90 because they're complementary, doesn't this other guy have to be 30 degrees in that case? So just one of these dudes, however you want to make it, but like 30 degrees. And I got to call them like angle 3 and angle 4, I guess. But those two have to add up to be 90 because they're complementary. And they're not supposed to like touch each other basically because they're non-adjacent. So there's tons of different ways you could have drawn that, but that's the way I did it. But this was kind of like a little preview into something called the complement of an angle. If I'm already given an angle, like I started with that 60 degrees, I was forced to make the other one 30 degrees because that's what makes it complementary. They have to add up to be 90. So if this dude right here is 30 degrees, if there's an angle given to you and they ask for its complement, we're going to do 90 minus 30 basically and get 60 degrees. And no, you don't have to show that work right there, but just kind of showing you what I was doing. And if I was given a 21 degree angle to find its complement, I would do 90 minus 21, which is 69 degrees in that case. If I was given a 76 degree angles, then I would do 90 minus 76, which is 14 degrees. And then if I had an 89 degree angle, it's 90 minus 89, which is 1 degree. Remember, you don't have to show any of this work, but I'm kind of setting this up here. And now check this guy out. The complement of 110 degrees, it would be like 90 minus 110, which is like a negative 20 degrees, and that doesn't work, right? So there is none to that. If you have an angle that's bigger than 90 degrees, it does not have a complement, so there's no such thing. But all this was just like a setup for the generic situation if you had an X degree angle. Here, if we had a 30, we did 90 minus 30. If we had a 21, we did 90 minus 21, 90 minus 76, 90 minus 89. It's just whatever they gave us right here, we did 90 minus that. So in general, if they give us an X degree angle, it's 90 minus X. And then we throw the whole mamma jamma in parentheses and put a degree symbol. So this is just the generic way for an abstract situation to where whatever the angle is that they give you to find its complement, you do 90 minus that guy. It doesn't work if you do like X minus 90 because that's going to be negative in that case. So it's got to be 90 first and X second. Then, if complementary means that there's two angles that add up to be 90, supplementary is two angles that add up to be 180 degrees. So two angles that add up to be 180 is called supplementary. So here they ask us to draw a pair, that means two, of non-adjacent, so they're not going to touch each other. Supplementary, they got to add up to be 180. Angles 8 and 9. So I will do this. And if this guy right here, let's just call him 80 degrees. So we'll call him angle 8. And then to find the supplement to that guy, he's going to have to be 180 minus 80, which is 100 degrees. Sorry, I hit the wrong button here. So I got to draw myself a 100 degree angle. And if I'd start with the right direction, that'd be even awesomer. So 100 degrees, we'll call him angle 9. And those, they don't touch each other, and they add up to be 180. So non-adjacent supplementary. To draw a pair of adjacent supplementary angles, there's a cheat code again for that. If they touch each other and they got to add up to be 180, bro, that means they're going to form a line. So like basically, if you just draw yourself a line right here, bada boom, and then have some sort of ray branch off of it. So then those two angles right here, angle 6 and angle 7, they totally touch each other and they will form a line. So if this is 60 degrees, then that's got to be 120 degrees. You see, like, they have to add up to be 180, but two angles that touch each other and form a line. Right there, we'll learn next time that that's got a fancy name. Let's find the supplement to all these guys. If complement was 90 minus the given angle, supplement is 180 minus the given angle. So that right there, 180 minus 50 is 130. 180 minus 80 is 100 degrees. 180 minus 90 is 90 degrees. 180 minus 125, again, you can always use a calculator on this. But we're just getting up 55 degrees. And then 180 minus 110 is 70 degrees. So in general, if you had an x degree angle given to you, the supplement to that is 180 minus x. And then throw the whole puppy in parentheses and put degrees on the outside of that bad boy. So complements, supplements. Easy way I get students to remember that is, like, they know one of them's got to be add up to 90, one of them's got to add up to 180. So if you do complement, which starts with a C, and supplement, which starts with an S, doesn't C come before S in alphabetical order? Well, complement goes with 90 and supplement goes with 180. So like alphabetical order matches up with numerical order. Like C comes before S, 90 comes before 180. So complementary, supplementary. And then finally, last word of the day is perpendicular. That's if lines, rays, or segments that intersect at a right angle is what perpendicular. It could be a couple of lines, a couple of rays, a couple of segments, or any combo of those. If anything like geometrically that is like linear intersects at a right angle, that's called perpendicular. The symbol in the picture, can you see that we've got this blue line DB right here and this green line AC right here? Do you see the symbol in the picture, that right angle box? The right angle box shows us, hey, those intersect at a right angle. And then the symbol in the sentence, you may have seen this before and you maybe not, it's this upside down capital T right here. It's like an upside down capital T is perpendicular. And what I mean by a sentence is this. Like, you see how they say, hey, we've got a sentence, line AC is perpendicular to line BD. Well, if you remember, mathematicians hate to write. So they say translate all this English into math. So line AC, pretty simple right here, isn't that the two capital letters next to each other with the line bar, is perpendicular to, so perpendicular, we will use the upside down capital T. And then the last thing right here, line BD. So that's what it looks like in math, right? Line AC is perpendicular to line BD. What does it mean? It means they intersect at a 90-degree angle or a right angle in that case. So if we do this, it says find the value of x and y so that line NR, Buddha, is perpendicular to, that's what that means right there, line MQ. So basically you're trying to say, okay, they want this to happen. It's kind of weird that they already have the right angle box in there, but so it's like they gave it to us. But find the value of x and y. Well, let's check them out. All right, let's check out x right here. You see these two dudes have an x in their expression, so I'm going to focus on them. So right here, this orange angle and this blue angle right here, you see, like, they, if you put them together, is supposed to be this entire thing right here, which means that's supposed to be 90 degrees if they're perpendicular. So what we do is we just put them together. And by put them together, I mean let's add them up. So it's like 5x, that's this guy right here, plus that 1x should add up to be 90. And to me, if you can handle adding those together in your head, because these are like terms, 5x plus 1x is 6x, that's going to equal 90. This is for sure work that needs to be shown right here. If you can do this part without writing it down, I'm okay with that. But we're going to start right here, and then we solve. To get rid of this times 6, we will, of course, divide by 6. So 90 divided by 6, and x turned out to be 15 in that case. So we have solved for x, and now to solve for y. It's kind of weird on that one. It usually stumps a lot of people, but this entire angle right here, this is the only one with a y with it. Well, bro, if these guys are supposed to be perpendicular to each other, then that guy right there by itself, that 9y plus 18, he's this entire angle. Well, he's got to be 90 degrees. So we will solve by first getting rid of this plus 18 by subtracting 18. And 90, you don't need the degree symbol there, bro. 90 minus 18 is 72. And then we would divide by 9, and 72 divided by 9 is 8. So we'll just circle our answers right there. We have found x, and we have found y. Because they were supposed to be perpendicular, which means they're supposed to add up to be 90 degrees. So let's try that with some other stuff. We're going to put all this information in the picture. Right, so it's helped people, especially if you're struggling finding angles. That's very, very normal. But they say the measure of angle EBF, I'm going to go highlight him for the benefit of my eyes, from E to B to F, right there. He's 3x plus 10, so I'll put that in the picture. And they say then the measure of angle DBE, so I'll pick a different color highlighter. Measure of angle DBE, so from D to B to E. You don't have to highlight any of this stuff, but you do have to put the info in the picture. So you need the x, you need the 3x plus 10, but the highlighting is just for those who struggle seeing stuff, and highlighting makes the visual game a lot easier. Then they say that ray BD is perpendicular to ray BF. Well, that means that this and this have to add up to be 90 degrees, right? So we can say the 3x plus 10 plus the x add up to equal 90. Again, if you could handle adding those together without writing it all down, you just combine your like terms. Here's some x's, so that's 3x plus 1x, which is 4x. Remember, they're on the same side of the equal sign, so we combine them together. The 10 is still right there. So this right here, if you can start with that, I'm good. Then let's subtract the 10. 90 minus 10 is 80. And then divide by 4. 80 divided by 4. I believe that's going to be 20. We'll double check with our calculator. Heck yeah, brother. So we have found the value of x right there. And then finally, let's do one more. Measure of angle EBF again. So from E to B to F, 7y minus 3. Putting that in the picture. Measure of angle FBC, so a little different guy right here, is the 3y plus 3, putting that in the picture. And then find the value of y so that these guys are perpendicular. Let's see if we can add these together without like writing that first step. So we're just going to have to add our like terms together. So these are like terms, 7y and 3y. If you add them all together, that's 10y. And then if we add our negative 3 and our positive 3 together, well, negative 3 and positive 3 is 0, so I don't even need to write that down. So 10y should equal 90 because I added these two together. Again, for those who are a little like, what just happened? I took that plus this and set it equal to 90, and I combined all my like terms. There's 10y, and then there's 0, and that's supposed to add up to equal 90 in that case. Well, then I'll divide by 10, and y should equal the 9, baby. So pretty sweet, man. Perpendicular, complementary, supplementary, and adjacent were the words of the day. Let us know if you have any questions. Have a good one.